Okay, we're back to do our 2 examples of what your learning target is, which is graphing from standard form. So your instructions are graph each function by finding its vertex, axis of symmetry, and y-intercept. Use symmetry to plot at least 2 additional points. Then for these, we're going to tell whether the vertex is a minimum or maximum and describe whether the graph is increasing and decreasing. Okay, so actually we do need to find the axis of symmetry first using our little formula. If we don't remember that, it's x equals negative b over 2a. So I need to identify my a, b, and c. In my first function, f of x equals 3x squared minus 6x plus 1. A is 3, b is negative 6, and c is 1. So my axis of symmetry, x equals negative, then b, that's a negative 6, over 2 times your a value, which is 3. So if I go ahead and multiply negative times a negative, that's going to give me a positive 6 on the top. On the bottom, 2 times 3 is also 6. 6 over 6 reduces to 1. So my axis of symmetry is x equals 1. Don't know why I put a negative there. There we go. X equals 1. Okay, so let's go ahead and graph that on our graph. So for axis of symmetry, just, we use a dotted line because it's really not part of the graph. It just helps us know where the middle of our graph is. Okay, now we are going to go find the vertex. Remember, to find the vertex, we actually already know half of it. We know the x-coordinate is 1. To find the y-coordinate, we plug 1 into our function. So we're going to find f of 1. So that's 3 times 1 squared minus 6 times 1, then plus 1. Okay, 1 squared is 1, so that's 3 times 1. Negative 6 times 1 is negative 6, and then plus 1. So this would be a 3, and negative 6 plus 1 is negative 5. 3 minus 5 is negative 2. So I put in the x value of 1, and I got out the y value of negative 2. So my vertex is the point 1, negative 2, and I'm going to go plot that at that point. The easy part is our y-intercept. If we remember, it's just the point 0, c. C is 1. So I'm going to go plot that. Now here's where we're going to use symmetry. If I know this point is on my graph and that axis of symmetry will help us plot another point, just reflect that point across the axis of symmetry, and we have another point on the graph. All right, then I said use symmetry to plot at least 2 additional points. So we could find another point plugging in any x value we want. For instance, I could plug in, just because I already have a point at 2, maybe I'll plug in the x value of 3. If I put f of 3, I can go 3 times 3 squared minus 6 times 3 plus 1. This is 3 times 9 minus 18 plus 1. 3 times 9 is 27. Negative 18 plus 1 is negative 17. 27 minus 17 is 10. So I put in 3 and I got out 10. So that's just another point on my graph. You can plug any x value you want in. I just decided to choose 3. So now this point is 2 to the right of my axis of symmetry. So I could count 2 to the left, and I know then that the point negative 1, 10 is also on my graph. So 5 points, that's a good amount of points to draw my parabola as best I can, putting arrows. It shouldn't really be pointy down here. It should be curvy. Okay, now the last thing we need to do is identify the vertex as a minimum or maximum. Since this graph is opening upwards, the vertex is a minimum. This point right here is a minimum. And because it's a minimum, as I come in and look left to right, my graph on this side is decreasing until I hit the minimum, and then it's increasing. So we say decreasing where x values are less than 1, less than our, like to the left of our line of symmetry, and it's increasing where x values are greater than 1, to the right side of our axis of symmetry. Okay, let's move on to B. G of x equals 0.5x squared minus 4x minus 2. We're going to start with the axis of symmetry. using x equals negative b, which is a negative 4, over 2 times a, which is 0.5. I guess I could have written my a, b, and c before I got started. A is 0.5, b is negative 4, c is negative 2. Okay, well, this also, these negative times the negatives cancels, and that gives me a positive 4. 2 times 0.5 is 1. 4 over 1 is 4, so my axis of symmetry is at x equals 4. Going to go graph that on the right over here. Here's x equals 4. I know my vertex falls on this line at x equals 4, so I'm going to go ahead and plug in 4 into my function. Okay, g of 4 equals 0.5 times 4 squared minus 4 times 4 minus 2. So that's 0.5 times 16 minus 16 minus 2. Half of 16 is 8, and then I can combine the negative 16 and negative 2 to be negative 18. And 8 minus 18 is negative 10. So I put in 4 and I got out negative 10. I'm going to go plot that. That's way down here. There's my vertex. Easy part is my y-intercept. Remember, it is 0, c, and c is negative 2. So 0, negative 2. Then I'm going to use symmetry, and I'm going to count. That's 4 units away from my axis of symmetry. So I'm going to go 4 to the right on the other side, and I have another point at 8, negative 2. Finally, I'm just going to plug in another number to find another point on the graph that I could reflect over the axis of symmetry as well. I'm just going to plug in 2, g of 2, 0.5 times 2 squared minus 4 times 2 minus 2. 0.5 times 2 squared is 4. 4 times 2 is 8, so I have minus 8, then minus 2. 0.5 times 4 is 2, and then negative 8 minus 2 is negative 10, and 2 minus 10 is a negative 8. So an additional point that I just found is 2, negative 8. So if I go plot that, that's down here. Reflect that 2 units, the axis of symmetry, so 2 units on the other side gives me another point. And I can graph my parabola. Ooh, that's beautiful. Okay, last but not least, this vertex is a minimum. So on the left of this, my graph is decreasing. And we say it's decreasing for x values less than 4, because that's where our axis of symmetry is. Then it is increasing after our vertex for x values greater than 4. Okay, I will see you tomorrow.